Hello, for today's lesson we are talking about inverse trig functions. So we have our inverse sine, our inverse cosine, and our inverse tangent. So what these inverse functions do is they're going to take our angle, angle ratio, so the ratio of sides, to the angle measure. So if we don't know the angle measure, but we know how the sides relate to each other, we can then use our calculators to find that angle measure. So we know that sine is opposite over hypotenuse, so inverse sine, so I write it as sin with a little apostrophe of little exponent of -1. And that exponent isn't an exponent like you think of it. It just means that I'm swapping the input and the output. So usually my output is the ratio of sides, so now my input is that ratio of opposite over hypotenuse. And then my output will be the measure of an angle. Okay, cosine inverse, COS with the little exponent of -1 is going to be adjacent over hypotenuse. And when I plug that into my calculator, I'll get the measure of the angle. And then tangent inverse is going to be adjacent over opposite. Opposite over adjacent, I mean. And then I'm going to get the measure of the angle out of there. On your calculator, what you're going to do first is you're going to press the second button, and then you're going to press your sine, your cosine, or your tangent button. Sorry about my dog. She wants to go outside. Piper, wait. And you can see that when you look at those buttons, sine, cosine, and tangent, right above them are these little things that say sine inverse, cosine inverse, and tangent inverse. And so how you are getting to those options is by pressing this second button, okay? Great. Let's do an example so you can see how all of this works. So if we have a triangle here with side lengths 2.4, 3.2, and 4.0, and we want to find the measure of angle L to the nearest degree. So I'm going to highlight angle L, and I'm going to label my sides based on angle L, because that's my angle of interest. So remember that your adjacent and your opposite depend on the angle you're talking about, the angle of interest. So 4 is always going to be my hypotenuse, 3.2 is the opposite side, and 2.4 is the length of the adjacent side. Okay, so I know, let's go through and write all three of our ratios. So the sine of angle L is going to equal 3.2 opposite over hypotenuse 4.0. Cosine of angle L is going to equal adjacent 2.4 over hypotenuse 4.0. And then the tangent of angle L is going to equal the opposite over adjacent, so 3.2 over 2.4. So now if I want to do the inverse, what I do is I swap that input and that output, and then I put that little -1 exponent. Okay, so that's how I would write it. So then I could write that sine inverse of 3.2 over 4.0 equals measure of angle L. And then here, cosine of 2.4 over 4.0 would equal measure of angle L. Or I could also do tangent. So tangent inverse of 3.2 over 2.4 equals measure of angle L. So we don't always know all three sides. So sometimes you only will be able to do this with one of the trig inverse functions. Oh, I forgot my little exponent on the cosine inverse. There we go. So you would just use one of them if you only have limited information, if you only have two sides. But we are lucky in this case and we have all three. So what I would like you to do is practice plugging all three of these into your calculator and making sure that no matter which one you pick, you get the same answer. So I did tangent, and when I did tangent, I got that the tan inverse of 3.2 over 2.4 is 53.13. Okay, so that means that the measure of angle L is about 53 degrees. Okay, and I rounded to 53 degrees because the directions told me round to the nearest degree. Okay, so there we go. All right, Next, we're going to talk about some applications of angle of elevation, or applications of inverse trig or trig in general. So we have these things called angle of elevation and angle of depression. So what the angle of elevation and the angle of depression are, is they are, if you just look straight, that's a horizontal line. Like just look straight ahead, and we call that a horizontal line of sight. And then if you have to look up to something, the angle between your line of sight and looking up is called the angle of depression. And you have to look down at something, the line of sight from the angle from the line of sight down is the angle of depression. So up, elevation, down, depression. Okay? So angle of elevation is the angle between horizontal line of sight and the line of sight looking up. At an object. Okay, the angle of depression is the angle between your horizontal line of sight and the line of sight to look down at an object. Okay, so here you can see that we have a person standing on the ground. And if that person is to look up at the hot air balloon, here's their horizontal line of sight. And when they look up at the hot air balloon, that is my angle of elevation. Okay, so the angle of elevation goes between those two. Now, if there is somebody in the hot air balloon and that person looks out, their line of sight is straight out this way up in the air. But if they wanted to look down at somebody, then that is the angle of depression, okay? From that horizontal line down. All right, so let's look at an example here. So here we have a mountaintop. We have a person standing on a hill, and then we have a cabin down in the valley. So describe each angle as it relates to the situation shown in the picture. So how you do these is you would say angle of, and then elevation or depression from blank to blank. Okay, so that's kind of the form of the sentence. So angle 1. So angle 1 is if we're at the peak, the vertex is at the mountaintop. Okay, so that's our starting point, is where's the vertex, which line's horizontal to that, and from there I go down. So that is an angle of depression from mountain peak to the hiker. Okay, great. Angle 2, here's the hiker's line of sight, so I know it's from the hiker, okay, to, and then it goes up, angle 2 goes up to the mountain, okay? So angle of elevation from hiker to mountain peak. Great. Next one, we have angle 3, which is also from the hiker, but now they're looking down at the cabin. So this is angle of depression from hiker to cabin. Then our last one is now if we are down in the valley and we are looking at the cabin, so the cabin's line of sight is here, and then they look up to the hiker, okay? So angle 4 is angle of elevation from cabin to hiker. Great. Last example. So to find the height of Delicate Arch in Arches National Park, Utah, a surveyor levels, I don't know how to say that, theodolite, with the bottom of the arch. From there, she measures an angle of elevation to the top of the arch. She then measures the distance from where she stands to a point directly under the arch. Her results are shown in the diagram. What is the height of the arch? Okay, so I'm going to draw this triangle separately. So if I draw my triangle so that it looks like a right triangle, I have 36 feet here. I have X feet here. I know this little piece down here is 5 feet. And then I know this right here is 48 degrees, okay? And we have an angle of elevation, right? Angle of elevation means I'm going from her horizontal line of sight up. And her horizontal line of sight, of course, starts 5 feet above the ground because that's how tall she is, okay? Short like me. Yes. Gotta love those short people. Okay. Here we go. So if I look at this triangle, I have my angle of interest is this angle right here. So I'm going to label all my sides according to that. So 36 feet is the adjacent side. X feet is the opposite side. And then the side I don't know anything about is the hypotenuse. So if I think about my ratios, so sine is SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I don't know the hypotenuse, so I'm going to eliminate the two trig functions that use hypotenuse. So that means I'm going to be working with tangent function for this. Okay, so the tangent of my angle, so 48 degrees, I know the measure, equals opposite x over 36. Okay, I don't need to use inverse functions, okay, because I know the angle. Inverse functions are only used to find angle measures. I already know the angle. That's not what the question's asking. So now I'm solving for x. So to solve for x, I'm going to multiply both sides by 36. And it cancels here. So then I get that 36 times tangent of 48 degrees equals x, and you can plug that into your calculator. Your calculator is smart. You don't have to do tangent of 48 first and then multiply by 36. You can type it in just like that. So 36 times the tangent of 48, and we should get 39.98 or 39.98. So x equals 39.98 feet. But then we also have to add, don't forget, we have to add the little 5 feet to find the total height of the arch. So my arch is 39.98 plus 5 feet gives us 44.98 feet tall. Okay, fantastic. All right, go ahead and try your homework.